Frederick Harper is a principal developer advocate at KubeFirst. He helps developers and develops be successful with their Kubernetes journey. He has also shares his passion for technology on the stage at various events. He's helped build successful and healthy communities at Microsoft, DigitalOcean, and Fitbit. He's also the author of a book, Personal Branding for Developers at A-Press. Behind the extrovert and his passionate individual who builds in the power of communication, Ant Cat videos. Thank you for listening. Without further ado, meet Frederick Harper.
Thank you. Oh, did I start there? Can you hear me? Yeah, actually, I usually don't need a mic, but I think they're recording. That is luxury, having an intro. Thanks, appreciate that. That's gonna be a quiet day, so you're gonna have like a private talk just for you folks. Super excited to be here. My name is Frederick Harper. As I forgot your name, I'm really bad with name. Yeah, so thanks for the intro. My name is Fred, super happy to be here. Actually, that is my first time at SCaLE. Second talk yesterday. I don't know if some of you were in the talk yesterday. I gave a talk about like what the heck is Kubernetes. Basically an introduction about like, you know, that word that we hear quite often, and sometimes we may not know what it is about. As the intro said, I'm a principal developer advocate at KubeFirst. What does that mean? My job is to give love to developers. I'm the friendly, social, approachable, technical face of the company. And during the talk, feel free, if you're on Twitter, I'm not going to say X. I'm still calling that Twitter. There's no way I'm going to call this X. Yeah, I know, it's just like a stupid branding. Anyway, that's my opinion. But I'm F Harper on Twitter, so feel free to tweet stuff that I share. Disagree with things that I'm going to say. Take pictures of the slides, of my beautiful face, whatever you want. Let's connect on Twitter. Let's connect on LinkedIn. And on that note, today I'm going to talk about Argo CD. Basically introducing you to Argo CD and talking a little bit more about like Argo CD waves, which is the title of the talk, Surfing the Argo CD wave, which is a little bit weird because I don't surf, but still, that's going to be the talk today. We only have an hour together. I could probably talk about Argo CD for a longer time than that. So today, when I was creating that talk, my goal was to introduce you to what is Argo CD as a tool that will help you in your cloud native journey and trying to help you to get started with Argo CD. So you can go back at home, you can go back at work and try the application, try the technology, or at least try to get your hands dirty a little bit with the technology. So obviously we won't see everything about Argo CD today, but hopefully that's good enough to either tell you like, hey, that's the technology that makes sense for me, or yeah, no, what Fred told us for the last 45 minutes is bullshit. It's not interesting to me. So you decide what makes sense, but I'm super excited about that technology. For this talk, I expect some basic knowledge of some technology so we can move faster to the rest. So I expect that you have a little bit of knowledge about Kubernetes. So I'm not going to go in details. You don't need to be an expert. You need to know a little bit how it's working, how it is, what is Kubernetes. But don't be afraid if you're not like someone who's using Kubernetes every day. You're still going to get good information about Argo CD. I expect you to have a little bit of knowledge about Helm. Again, not that important actually. I should probably even have removed that on that like warning slide because I'm not even gonna use Helm, I think. I don't remember actually my talk, so, but I assume I don't use it that much. A little bit of knowledge about Git or things like GitHub and YAML, because again, I'm not gonna explain YAML, but I'm gonna show some YAML file where I'm gonna explain a little bit the content of those files. Again, those are really, you just need to have like high-level knowledge about those technologies to really be able to follow that talk. You do not need to be an expert. Specifically about things like YAML, I was saying in my talk yesterday when I started to go in the cloud native way, God, I hated YAML. I was a JSON person. YAML was like a pain in my ass. That was terrible. I hated it so much. And now, it took me a while, but now I'm a huge fan. I don't have to put brackets everywhere. I don't have to put double quotes everywhere. It seems like it's a little bit cleaner when you have to define something. With that said, let me start, let me start with a quick introduction about GitOps, because that's going to be important to understand a little bit, just really, again, high level, the GitOps principle, to understand what I'm going to show you when it comes to Argo CD, because even before explaining Argo CD, let me just do a quick introduction. So, what we used to do, as developer, we have our code. We put our code on Git somewhere, or if you've been doing that for a long time prior to Git, you were doing that on like SVN, or like, was it CVS or CSV? I don't remember. That's a long time ago. I still have nightmare. Say that again? Which one? Oh God, no. Please, no. No, no, no. Or what was the Microsoft technology to, say that again? Yeah, that thing gave me nightmares. Like as much as like when with every technology, I think we have like a little bit like, oh no, things are changing. But like once you get used to it, like I get used to Git and I was like, oh my God, that is so much better on so many levels. Like it's a little bit more complicated to get the grasp out of it, but once you have it. Anyway, I'm going in all directions. So we put our code on Git, whatever, GitHub, GitLab, something internally. We have a CI CD pipeline that basically deploy our stuff, and we put this on the cloud, whatever the cloud means. That could be on-prem, that could be a server in your wardrobe, I don't know why I struggle with that word in English, at your house. You just put your code somewhere. Actually, your like continuous delivery platform will put the code out there. And this is basically what we were doing mostly at the beginning when we were talking about DevOps. Slowly, and part of GitOps, we are adding infrastructure as code. You know, things like Terraform, where you define your infrastructure with code, which is a thing of beauty. I love that so much. So you may have done that in your DevOps journey or as a developer, but now it's really part of GitOps. So now it's an important part. You have to do infrastructure as code. And you're also going to put your configuration. So you put everything in Git. Git become your source of truth. But there's also other difference in the way that you're going to deploy your application. So you know that CI/CD, we always say CI/CD like they're like brothers or sisters and like they need to stick together. Now, we separate them. Because at the beginning, there are two different things, but we always talk about CI/CD. But now, you still have your continuous integration. You still have like that CI pipeline that do some testing, that release some like new versions, new chart, new images, do whatever you have to do in your CI pipeline. But now we decouple the CI and the CD pipeline. And another thing that is different is that prior to that, Git was pushing things to the CD platform mostly, and the CD platform was doing things, deploying and stuff like that. But now, when it comes to GitOps, the CD platform will, and please, if there is a better way to put that in a diagram, like the pulling image, I tried to do it, but like the CD will go and pull the information and bring it back to the CD platform. Why? To deploy that to Kubernetes cluster. So GitOps is really a way of doing things that is really specific to cloud native. Some pieces of it are part of like what we used to do every day, but they're put together. And why the CD is pulling the information from the Git now, it's because on your cluster, you have an Argo CD agent that basically clone your Git repo, and I will talk a little more about that, why it is happening. So again, Git become your source of truth, where you put everything in your Git repository. And this is GitOps in a nutshell. You don't have to understand everything about what I just said if you're new about GitOps. Just understand that there's a little bit of difference between how we were doing things when it comes to DevOps and how we do things when it comes to GitOps. But now, there are some benefits about using GitOps. I'm not just saying that because like that's the way I prefer to do things. It uses familiar tools and processes. You use Git or whatever Git server you're going to use, GitHub, GitLab, whatever, you just use Git. So if you're used to Git in your day-to-day processes, you are basically good to go with GitOps. Uh, it also uses maybe infrastructure as code. You may not be new to that. It's not new to GitOps. It's a technology that we're using for a couple of years. So like people doing DevOps, they're still going to use things like Terraform to create their infrastructure. So you're familiar with the tool and the processes. It helps you to do faster deployment and iteration. And it's easily reproducible because Git is your source of truth. So no more things that are running only on the server anymore. Your source of truth is Git. It's not the server anymore. So it ends up like you won't have like, oh, it's working on my machine, or it's working on my server, and it's not working on the other server, or we change things directly on the server. Like everything is on Git, which brings no cluster drift. What is it? You know, we've all done it. If you said no, you're probably lying. There's something wrong on the server. What are we going to do? We're going to go quickly on the server to try to fix things. We're going to fix things on the server, and we're going to say, hey, you know what? I'm going to refactor that later, or I'm going to put that like in our source code later, and later usually never happen. What's happening with GitOps? Because Git becomes your source of truth. And I will tell you a little more about like the sync status of Argo CD, but like what's going to happen is that Argo CD is going to look in your Git, it's going to look in the cluster, and it's going to say like, hey, like there is something different on the server, or the other way around, depending if you're a positive or negative person. Like Argo CD will look and like, hey, there is something different between the Git repo and the server. And we'll try to reconcile that so the server reflect what is in your source of truth in Git. It brings greater collaboration because everything needs to go to Git. And with that, hopefully you have a proper review process, meaning that like if I want to change something on my Kubernetes cluster, I'm going to have to go in Git. I'm going to have to do a pull request. I'm not going to commit directly on main. I'm going to do a pull request. And hopefully someone on the team is going to review my pull request, approve it, decline it, ask me for changes. It may be a pain if you don't have proper process, but I feel like you should have those processes in place, having someone review your pull request. And because now, again, I'm going to be tiring with that. Everything is in Git. You can use that process of like pull request review to be sure that it brings, from my point of view, greater collaboration and better quality of whatever you're going to put on your server. It brings, I struggle with that word in English. I really need to find a synonym, but like auditability. Was that good? Yeah? Okay. English is not my first language. French is. So auditability, because, again, everything is in Git. So you have the Git logs. You did a pull request. You've seen who approved it. It's not about blaming people. It's just easier to understand what are the changes that happen in the server, contrary to like, hey, Bob went on the server on the Friday night to fix things that we don't know about. Now everything is visible to everyone also, which brings also more security and the simplification of access control. Because now I don't need to give access to every developer on my team. Not that I don't trust developer, I'm a developer myself, but I don't need to give access to everybody on my team to my server. I don't even need to give access to everybody to Argo CD, or I can give them access like just to view only. What I give access to people is to my Git repo. On top of that, my CD pipeline doesn't need to have access to my server. Sometimes we're going to need to like have a connection, not sometimes, all the time. You're going to need a connection between my CD pipeline to my server so my CD can push things to the server. Now, because there is that agent in the Kubernetes cluster, you need that agent to have access to your Git repo. But from my point of view, I think it's a little more secure. I'm not a security expert, but I feel like it's a little more secure to do it that way. It's cost saving for all those reasons, and it's easily revertible. You can do rollback changes because it's just a question of, hey, you know what? We're gonna like revert the code that we did in the previous pull request, or we're gonna rebase the history and remove a commit or do stuff like that. And once it's in Git, the server will pick up the change and you're gonna be good to go. And lastly, because of all those things, you bring a simple stateless disaster recovery model. My cluster goes boom for whatever reasons. Now what I can do, I create a new Kubernetes cluster and I reinstall or redeploy everything that was in my Git repo. I'm not screwed. I'm not concerned about like having backups. I'm not concerned about all those things. I'm not concerned about the changes that, again, is there any Bob in the room? Okay, I didn't want to be mean to Bob in the room, but like, it's not about like Bob making the change on Friday evening on the server that, again, nobody knows about because I fixed something and now we need to redeploy for whatever reasons. We don't have that change anywhere. It was specifically on the server, but like, I lost the access on that server. So a lot of reasons to think about GitOps when you do your cloud native journey. So it's not the only way, but it's the way that when I talk to people about starting a cloud native journey, I said, like, you probably need to think about GitOps. Why I was talking about that? Because Argo CD was created, you don't have to use it as a GitOps CD pipeline, but it was created with GitOps in mind, and this is part of where the power of Argo CD comes from. Sorry about that. It's pretty cold there, huh? Yeah. I mean, I'm Canadian, and like, I feel like it's cold in the conference center.
You should try Ballroom tea.
Oh yeah? Is it like colder or like too hot? Steamy? Okay, okay. Yeah, so anyway, I was just like, I thought it was like just me. Maybe I caught something or like, no. But like, again, I'm Canadian, so I know cold, and that should not be cold. So anyway, now let's move to the main topic, Argo CD. That is, oh, whoa. That is the beautiful mascot of Argo CD, Argonaut. I just love it. So why I love Argo CD, it's not the only CD pipeline, CD tool, CD system, whatever you call that, CD application that you can use in your cloud native journey. There is a lot of like more traditional CD platform that you could use. There is also a CNCF project called Flux. Argo CD, it's open source. Also, it's not part of the CNCF project, but like it's open source. It's free, and it's part of Argo project, which have also other tools like Argo Workflow, Argo Events. But Argo CD, as I said, it's free, it's open source. I'm a terminal person. I don't know for you, I love the terminal. I love to do things in my terminal. But I'm not against a beautiful UI once in a while or to make things easier. And because there's a lot of information about things that I deploy on my cluster, having a nice UI is pretty cool. And the Argo CD UI is nearly flawless. And again, I'm not a designer, I'm not a UI expert, but I just love it. Which, when I do things with Argo CD, they have a CLI. I do things most of the time in the UI because I love it so much. I'm going to show you like the graphical interface that show you like the sync status and basically what's happening within your cluster. It's also easier to manage permission. I was telling you before, hey, for whatever reasons, it's not because you don't trust your developers, but you're a big organization, you need to manage permission in different ways than, let's say, a small startup. I can give like just a view access to people to Argo CD, and my developer can see like, hey, I release a new version, and it is in the GitOps repository. That is my source of truth. I want to see if it's deploying. I want to see like the sync status on Argo CD. You can give those different access. As I said before, Argo CD was created with cloud native in mind. So it's not like a previous platform that was there before Kubernetes was a thing. It was created for Kubernetes. It was created for, how can I say, standard Kubernetes usage, but really with GitOps in mind. So again, you can use it for without using the GitOps principle when you go cloud native, but if you do, and this is part of like why I'm giving that talk, this is where you get all the benefits of the Argo CD platform. One of the main feature, one of the biggest benefit is the real-time status. So what's gonna happen, you deploy something, you had an application, you update an application in your Git repository. Argo CD, as I said, has an agent in your cluster. It will check to see like, hey, like is there something by default, every 3 minutes, it's gonna check the Git repo. Actually, it's gonna clone the Git repo to the latest version. Gonna check like, hey, is there something that changed based on the previous Git version that I have and now? And if something changed, it's gonna start to do whatever you tell, like in your probably YAML file, what to do on your cluster. And you're gonna have access to the sync status. You're gonna have access to the current state, so the current state of the cluster right now. So what's the current state of my cluster? But also, what's the desired state? So if there is a cluster drift, if there's something different between Argo CD and my Git repo, I'm gonna have access to that. But on top of that, I'm also gonna have access to the app help. And I'm going to explain, actually, I'm going to show you this right now, right after talking about repositories. So one way to make Argo CD behave like a GitOps platform for your cloud native is to add a repository. So there is an option in Argo CD where you can say like, hey, I'm going to point to you to my source of truth that should be reflected in my cluster. And you do that by pointing in Argo CD to Git repo. So at KubeFirst, what do? We call this like simply GitOps repo, and that becomes our source of truth for our, in our case, production server, development server, or whatever the server that we want to deploy, the cluster that we want to deploy. If I want to be transparent, because I want to be transparent, it's also possible for you to point repository to a Helm repo. But I would suggest to point this to a Git repo because of GitOps. It makes really your life more easier. So let me show you. Here, actually, I'm going to use K3D. I'm going to create a new cluster. Actually, K3D, I said. There is also a technology called K3S, but K3D is basically, I don't know, like Minikube or Kind, helps you create like a Kubernetes cluster locally on your machine. It uses Docker in that case. So if I go in Docker here, actually should probably have created that before the talk, but it's going to take 2 seconds. I'm going to have containers running with basically, quote unquote, Kubernetes here. And actually, that's not what I'm going to do in that demo. Let me switch to another cluster that I have. So it's a cluster that I created in Civo. I don't know if you know K9s. That's my best friend. I mostly don't use kubectl anymore for most of the things. Actually, I started to forget how to do things with kubectl or kubectl, if you say it wrong. So kubectl, K9 is just like the way of living for me. And something's happening on my cluster, but it doesn't matter. It's going to be good enough. So right now, I'm showing all the pods that I have in that cluster. And what I'm going to do, I'm going to be just a little bit tricky. I'm going to install Argo. Nope. Wrong icon. I'm going to go in VS Code here, and I'm going to deploy customize Argo CD for one reason. And actually, you know what? I'm going to explain that to you a little bit later, why it makes sense. But right now, if I close that thing, you're going to see I'm basically creating a namespace, Argo CD namespace. I'm going to use the manifest to install Argo CD, so the one provided by Argo CD here. If I go here, this is what I'm doing. So Argo CD, I'm making this secure. I'm creating the namespace Argo CD, and that's kind of it. So, oh no, actually there is this one. This one, I'm going to explain it later. It's customization Argo CD, but you could just basically do Helm install and use Argo CD. So what I'm going to do here, I'm going to do, let me go to manifest, and I'm going to do, actually, I'm going to use the one I have in the workshop. So I'm going to apply the manifest to install Argo CD in my cluster. So what's going to happen now, I'm going to install Argo CD in my cluster. I'm going to show you an empty Argo CD cluster, but after that, bear with me, I'm going to show you a full-fledged production-ready one with a lot of things in it. So while it's doing that, actually, let me show you the other one. So I created a cluster. It's not a talk about KubeFirst, but I've created a cluster with KubeFirst. It's a free open source platform. It's what we do. We help you to create actually production-ready, full-fledged platform because, you know, creating a cluster is the easy part. But after that, you're not quite ready to deploy your application. You know, you probably want something to manage your secrets. You won't have like a CD pipeline. You need something to manage like the certificate that you're going to need to access your application outside. You need something to, maybe if you really want to do GitOps, have Atlantis, which is a tool that's going to help you to manage Terraform, apply within your Git processes. So what we do is that with that tool, you select the public cloud, you create a cluster that gives you that beautiful interface. But my point is, let me go to Argo CD here. And now this is like a really nice Argo CD that I need to connect to. So what we do also, when we create a cluster, we install Vault. We use it like as a Hawaii DC platform for SSO connection with other services. So it's why Argo CD redirected me to Vault. It's not going to happen in the default installation on Argo CD. So here I'm just logging with my username and password. Now I'm going to be in Argo CD. What do we do at KubeFirst? We use the App of Apps pattern, meaning that like there is one application that I call registry here, and let me make that a little bit bigger. And here, this is what I'm going to see. I'm going to see all my application, everything that is deployed in my app is going to be here. I don't know if it's big enough, but oh, the other one. You're going to see here, there's that little heart. It's basically saying that, like, hey, my Ingress and Nginx component, my application here is LT. I have the check mark here. It's green. It means that it's synced. So I have here, let me make it even bigger. So here I have, like, the latest commit that I have in my GitOps repo. I have what was synced. And right now, everything is LT. Everything is synced. The repository that I was talking about before is in settings. I have repository, and what I've done, I connected my Argo CD to my GitOps repository. So now, everything that I'm going to do in my GitOps repo is going to be reflected here. And let me show you my GitOps repo. If I go here. So the thing with GitOps, it's not really, how to call that, standard per se. There is a group, a working group, working on defining the principle and like sharing some kind of like best practices, but like, there is no one way to like define your GitOps repo. So what we do here, we have the Terraform folders where we put different Terraform files. So this is how we structure GitOps repo. I shared that because that could be interesting to understand. But like if I go here, I have a couple of Terraform files. So I have a CVO folder because I created my cluster in CVO. If you don't know CVO, it's a smaller cloud provider, a little bit like DigitalOcean. What is nice is that you know what you pay for. You don't have like surprise billing at the end of the month. But I'm going to have my Terraform file here. And I also use Terraform because there is like GitHub provider to create the repos that are connected to whatever I want to deploy in my cluster. So I have the repos here, and I'm going to have like the repositories that I created, which is only 2 with my KubeFirst deployment, but you get the gist. Everything is in my Terraform folder. What becomes, oh, even users, actually, we even manage users. So here, let's say I have, not this one. I even create users in Vault, so my users can have access to different part of my ecosystem that I deployed, but also I use that to have like a developer and admin groups. So the GitHub repositories that I'm going to create part of my projects, I'm going to be able to give them different access. So if I would like to have a user like this one right now, I would just uncomment that or like basically create a new model. But again, everything is part of my GitOps repo. But now let's go to the more interesting stuff. Here I have the registry. And we define that with different environments, but also different clusters, because when I created my clusters, I created like what I call my management cluster, which is what you've seen, but I also created like a production, staging, and development clusters. That were actually virtual clusters. So that's a nice technology. If you don't know, there is vCluster, a technology from Luft.sh that give you the opportunity to create virtual cluster, and they're nearly identical to like physical clusters. So that's perfect for testing stuff, to giving some like more ephemeral clusters to your team. The only thing is that your vCluster lives inside a physical cluster, so the resources depends on like the resources from your physical cluster. But I'm going in another direction. Here I have basically what I've shown you, which is my app of apps pattern. I have my registry YAML. I don't know if that's big enough. I have my registry YAML that define that basically say like, hey, you know what? Like everything you need to deploy from my app of apps is in that folder, which is the one that I'm in. So if I go here, I have all my application that have been, all the definition of my application that have been deployed with Argo CD. And I'm going to show you how to basically deploy an application. But just before that, let me see. I should have on my other cluster, I should now have Argo CD installed. and I have Argo CD installed. Let me just port forward here, which is probably not what I want to do in production, but for a demo, that's good enough. And now I have a beautiful, not really sexy Argo CD. So you could do like a Helm install, having Argo CD, and you're good to go. And what would be the next step for me is, if I want to do it the GitOps way, is go in repository, connect to repo here, or connect a Helm repository. But I suggest, again, a Git repo. And I would have Argo CD become my CD pipeline for my cluster. But there's another way to install application. I'm going to show you that a little bit more further in the talk. Is it good so far? That's kind of like a lot of information, but I think that's the way to go to at least get out of here after an hour and kind of like understand what is the tool. So there's a couple of ways to deploy application. If you want to do GitOps, the way to go is to define your YAML file, put your YAML file in your GitOps repo, and have Argo CD sync that for you. You can also use the interface. So within Argo CD interface, I can add new application, and I can define my application that would point to a Helm chart, that would point to a Git repository, that would point to a specific file that I want to deploy in my application. If I do that, though, Argo CD won't commit stuff to your GitOps repo. So that's not my preferred way to do that. But again, that's a talk about Argo CD, not just GitOps. So I want to show you all the opportunities, all the ways to do these. And the third way is you can use the CLI. Argo CD has a CLI. So in your terminal, you can install with your CLI in the Argo CD CLI in your Kubernetes cluster. Sorry. Actually, you're totally right. I never put the API here because most people don't want to go through the API route when you have the UI and the CLI, but you're totally right. Actually, this is what the CLI is doing. It's basically like doing like the in-between, like Argo CD and you is connecting to the API to access. But yeah, I should probably even add that to the talk, because you may want to do that if you want to do some automation that maybe you cannot do with the CLI. But the CLI is pretty good, though. You can basically do mostly everything you want with the CLI. So with that said, let's deploy an application, but the GitOps way. So here, that is so zoom. I'm going to go back here. No, I'm not in the right place. Let me go back to my GitOps repo here. And what I'm going to do, I'm in my registry folder. So again, this is the architecture that we decided to use for our GitOps repo. You don't have to do the exact same way. But what I'm going to do here, I'm going to go, oh my God, I cannot understand at that size. Let me, just for a second, that's way too much. So I'm going to create a new file called whatever, .yaml, and I'm going to cheat here. So what's going to happen is that I'm creating an application. I'm adding a YAML file in my GitOps repository. The kind is an application, but as you may see here, it's a little bit different than when you're going to do a YAML file that is specific to Kubernetes, so the API version is a little bit different, but the rest is kind of a little bit the same information. So I'm going to give a name. I'm going to put it in the namespace. I decided Argo CD. Here, there's something interesting, the sync wave. So I'm going to talk a little more about that later, and this is one of the things that I really love about Argo CD. So bear with me. Let's keep it to 0. It's the default anyway, the sync wave version. And I'm going to define here that I want to install a chart. So I'm pointing to a chart repo or repository. I'm defining the version that I want to install, the name of my chart, and sorry. And the rest is a little bit boilerplate, except that I also basically had 2 files in one. For the sake of the demo, I installed Ingress controller. So we're going to be able to access that application that I'm installing on Flappy on that URL. So just before I do anything, I pre-install the application before the demo, because hopefully I wanted DNS to be my friend, because you know it's never DNS, it's always DNS. So just to show you, right now it's not like working. I refresh, it was working. Hopefully DNS will still be in the air. And I'm going to commit. I'm going to do something that you should not be at home. You should not do this at home, kids. I'm going to add directly in main without having anyone reviewing my stuff because, you know, it's Sunday, nobody's at work. So I'm going to have that file. I'm going to commit this directly. Again, shouldn't do that. And I'm going to go back to Argo CD here. Please, 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 fast enough. So I'm not missing what's going to happen. Whoa, I zoom way too much. So, okay. Let me zoom again anyway. God, the zooming is bad. Okay. So, as you see here, the last thing is still my previous commit. I removed the application before doing the talk. So now sync is okay. The default sync time is every 3 minutes. But what I could do, I could try to refresh here. And Argo CD is going to say like, okay, I need to refresh my stuff. Go check in GitHub's repo. And it's going to say like, hey, now I'm checking stuff. And it's going to see like, hey, you know what? There is that new application that is here. If I click here, and I think I was not fast enough, I could have seen, maybe next time I'm going to put like a sleep job just so we can see. But anyway, I'm going to show you the sync wave after. There is the desired manifest, which is what is on my Git repo. There is the live manifest, which is what is now on my cluster. And we should have seen a difference from like basically everything because I just had the file. But like, let's say I do another commit, I upgrade the version of my chart. I'm going to come here. When it's going to sync, the difference is going to be like the chart version. And now it's syncing. So it's synced, but now things are being deployed. So if I go back here, and need to zoom down again because I'm going to survive that. If I go here, no, not this one. My ENJ Flappy here, my application. I go here, I have that beautiful view of like every Kubernetes object that was deployed to create my application. You know, I have a deployment, I have like services, I have replica set, I have my pod here, and everything seems to be healthy. So the heart, again, it's because things are healthy, meaning that like the endpoint that I defined or the default endpoint like Argo CD is like, you know, the application is great. And the check mark is because the sync is okay, meaning that like what Argo CD, the last thing that Argo CD saw in Git, the last thing that I refresh or that Argo CD sync automatically is the exact same thing. So now, if the DNS are with me, and I refresh that, I have my new application, which is the basically, what was the name of that game? Like Flappy Birds, which is amazing and super frustrating game at the same time. But how I deployed that, I didn't go on the command line, do you know, K or kubectl or kubectl, whatever you call it, applying my YAML file. I even didn't go in Argo CD because I told you I could go in here and say like new application, and I could basically define myself what I want to install here. My application, I can point to a Git repo, I can point to a Helm repo, and I define the path, the branches. I put the YAML file in my GitOps repo, and Argo CD did the rest of the job, which is what I really love about like the GitOps principle and that tool. Little trick about that. If sometime you're not too sure, I don't know how much experience you have with Kubernetes, but like if you're not too sure like how to define your YAML file for specifically Argo CD to like deploy it correctly, sometimes you go here in the interface, and once you input everything, instead of like creating, clicking create here, and really not doing it like doing a ClickUps way, which you should not from my point of view, you can just go here, edit as YAML, copy and paste your stuff, create a YAML file in your Git repo, and you are doing this the GitOps way. So that's one way of deploying an application. That is the GitOps way. That is the way that I really like to do. And oh, actually, let me show you. Do I have time? Yeah. Let me do that in 1 minute. Actually, if I go back here, and I go flappy array, and I say delete the file, comment on main, please don't quote me on that. If I go back here, oh, not this one. If I go back here, too many Argo CDs. Oh, it was here. And I go back to my registry, And again, I refresh. 10 minutes. Whoa, I talk too much. Anyway, this is the part that's going to refresh. It's going to remove my application, and it's not going to work anymore. The thing that I really want to share with you, and I only have 10 minutes because I talk way too much most of the time, is the phases and sync wave, which is the exciting thing for me. There is 3 phases of sync. There is the pre-sync, there is the sync, and there is the post-sync. Exciting. Meaning that, like, the sync is what we've done. You know, I had the application, I click something, it's saying it did the stuff. I can do things before, I can do things after. Decide whatever makes sense for you. What's really interesting is the waves of the sync. So, Argo CD, because you've seen, I deployed many applications. If I create a new cluster with all those applications, there is probably an order that I want to do stuff. Let's say I want to deploy WordPress, and I didn't use like the official Bitnami chart that had like WordPress and MySQL, but I want to deploy MySQL myself, and after that, WordPress. So what I want to do is I want to deploy MySQL. And once MySQL is responsive, working, and I can connect to it, I want to deploy WordPress. So I'm going to use the sync wave, which is a number that you've seen before, that the default is 0. You can go minus whatever to plus whatever. I suggest keeping it over 0. So Argo CD is going to decide, based on the number, ascending number, what is the thing that I need to deploy first, and what is the thing that I need to deploy after. If you have the same sync wave, Argo CD is going to be like, hey, I'm going to go by kind. And there's a full list in the documentation. I'm going to start with, like, is there like a namespace object? Is there a service object, a deployment object, and so on. And if you have the same sync wave, the same kind of object, it's going to go by name, ascending by name. So that is the magic of the sync wave. What I've deployed before is the part that I didn't tell you. That talk goes a little bit to shit with the change that happened in Argo CD 6 months ago, because by default, they changed how they manage the sync wave. So before, they were going exactly what I told you, but they were waiting for the application to be healthy before moving to the next sync wave. But for performance reasons, about 6 months ago, 7 months ago, they changed it, and now they're just waiting that the check mark, the sync status is okay, and they move forward, which it's probably what you don't want to do most of the time if you use a half of apps and wants to use the sync wave. So what I've done here, when I deploy my Argo CD on my other empty cluster, I basically redefine the old way, meaning that, like, hey, before moving to the next sync wave, wait for the application to be healthy. So it's basically what I'm doing here. So let me show you a sync wave, how it's working. So I have my boring Argo CD here. What I'm going to do, I'm going to deploy, actually, a hub of apps. And let me show you quickly the hub of apps that I'm going to deploy here with my super zoom Visual Studio that I cannot see anything now. Argo CD, sync wave. So I have a registry here. Again, that points to the exact same Git repo that have two YAML file, zero wave. That is also a hub of apps. That's going to point to my zero wave folder that have 3 kind objects, which are jobs. That is like a job, an object 0, an object 20, an object 20, and basically they have the same sync wave as the object that they are in. So I have my registry that have one hub of app that is to the sync wave 0, 0. I have another hub of app that is at the sync wave 10, and another app of app that, no, actually, that's all. Within those app of apps, I have a job that is at the sync wave 0, a job that is at the sync wave 10, and a job that is at the sync wave 20. So if I deploy that, so I did here, it's not a GitOps way, it's for the demo. People in the back may not see because the screen is a little bit weird here. But I'm going to apply this, so just kubectl apply half my file pointing to my repo. If I go in Argo CD here, that said that it was created. Probably need to refresh. Actually, I probably need to do the port forward. So hopefully, not going to miss my demo here. I killed key 9s too fast. Going here, I have my registry. What's going to happen? Oh no, I'm not on the right one. Sorry. Where did I deploy that? Can I? You can't see it here, but like that's kind of like messing up with my demo 8080. Avocados 8080. No, that was the nicest demo ever. Yeah, I know, that's sad. Why is it not happening here? Argo CD server. I'm in Argo CD sync wave. Oh, no. I'm good, sorry? No, that should be good. Okay, let me try on this one quickly. It's gonna work. Let me change my context. I don't know why it's not. Oh, let me do the K3D, this one. Let me try it quickly. Oh, I didn't deploy. God. Let me go on this one. Should work. Let me try to deploy this one. So, Argo, sync wave, registry YAML, cross your finger, it's gonna work. And, oh no, that's gonna screw up everything on my cluster. No, that demo was so sexy. Okay, so let me, it's kind of working, but that's not gonna work because I override the registry and that's gonna be an pain in the ass. Oh no, okay, it's working. So what's happening here ish, it's not exactly the demo that I want to show you, but what's happening here is that as you see, this one should be like not completely synced because I override the process. Now I just had a job that wait for 10 seconds. So this one is already done, this one is already done, but as you may have seen, the 0 job was started, the 10 sleep, which is like the sync wave 10, did not start until the 0 was done, and the 20 didn't start until the 10 was done. But if I go back here and I go to the next one here, the 10 sync wave, we're gonna see nothing. So that was a beautiful demo. My idea was to showcase that like I had a hub of apps at sync wave 0 that started to sync. Within that one, I had the job that was the sync wave 0, 1 at 10 was on 20, and they were going sequentially one by one. And the other app of app that was a sync wave 10 didn't start until the app of app at sync wave 0 was finished, because first I override that. And because it went about like, hey, they have different sync wave, so I'm gonna finish the app of app that is the sync wave 0, everything that needs to be deployed before moving to the other app of apps. So that was basically like the goal of that talk, was to show the sync wave. So hopefully it's not as exciting, not sure what happened. But in the end, what you get with Argo CD and GitOps is basically that. You get to the right, you get the same kind of process that you get usually. You know what? You do your pull request, actually Argo CD is gonna check what's happening, what is the desired state, gonna calculate the desired state, try to identify divergences, attempt to sync your information, provide the sync result to the interface, the API, which the API is like also using the interface, using the CLI, gonna demo that and do that process all over again and again and again until there is no cluster drift. So some resources if you want to get started with Argo CD, argoproj.github.io/cd, it's the place to be, it's the place to go. I usually have questions about like, oh, what's the difference between Flux CD and Argo CD? It is not the goal of that talk. This is a great article that is really sweet, short and sweet, give you like the really high level of difference. To be honest, I think at that point it's just a question of preference. What are you used to? What do you like? The thing with Flux is it's a great technology. The company that was working on it, they unfortunately, how do you say that? They went bankrupt. Yeah, I don't know. But there is still like a great open source contributor out there, and some of the employees continue to work at their new job on the project, so it's not dead per se, and it's a CNCF project, so hopefully it's not dead. But there are some differences. As I said, I told you why I prefer Argo CD with the beautiful interface, the management of permission. What is really exciting to me is how it was built. If you want to try Argo CD without having to do all the manual stuff that I've done, try Cube first. It's free. As I said, it's open source. That's going to create you the cluster that I've shown you with all the apps installed, configured, working together so you have like a production-ready cluster. And if you want to try Argo CD, you have any question, actually I should put there is also a Slack for Argo CD project. But if you're like, hey, it's intimidating with all those like Argo CD community, it's a big Slack, come to your Slack community. It's cubefirst.io/Slack. We have Argo channel for, we just call it Argo because we can help you with any project. Even if you don't use our product, we're just friendly people with an expertise, with an experience, with the love for Argo CD and the Argo project. So if you need help, we're going to be more than happy to help you. And with that said, I think I'm running out of time. If you have any question, please feel free. I'm going to stick outside of the room after to take more questions. You can send me an email, ping me on Twitter, ping me on LinkedIn. Let's connect on LinkedIn. Last thing, if you want to talk about Argo CD, you want to talk about cloud native, you want to talk about communities, you want to talk about cats, coffee, Buddhism, whatever, you just want to get to know each other, I'm offering free coffee chat. You go on fred.dev/coffee. It's a 30 minutes video call. It's just like, because I'm social and I hope a friendly person. So this is what I'm offering. And on that note, hopefully on the Sunday morning, that helps you to understand a little bit Argo CD and hopefully get as excited, even if you didn't have like the really sexy demo of SyncWave, get you as excited about Argo CD to try it within your cloud native journey and hopefully even maybe go a little bit the GitOps way. So I think that's it. Thanks for your time. You have time for, yeah, okay. If there is any question, comment, insult, I think we have 5 minutes or something.
Thank you very much. I was wondering how you set up your shortcut on GitHub. Like you put
Sorry, so I'm a little bit hard hearing, and because I put that, I removed my hearing aid. So how long have?
No, there's the shortcut on GitHub. Like you put a colon cube something, and then that populated all the YAML file. I was wondering how you did that. Did
Oh,
you
yeah, yeah, okay, so it's not related to Argo CD. I use a tool called Espenso. It's an open source tool. It's on GitHub, github.com/Espenso, and you can define shortcuts. Like my shortcut was like colon flappy-cvo. It replaced my stuff. I use this for everything and anything. You can specify, I want that shortcut to run only in my terminal. You can also have like regular expression to do stuff. So to be honest, like there is some like Git comments that I don't even remember how to write them, like more complicated one, because I just have my shortcut. Like if I go here and I do like, hey, I want to git commit or change, like I do GM, or like I remember this one, or git C, and like I do this for a lot of things, just make my life so much easier. And I've been giving talks for a long time, and I hate people that do a lot of like live coding, because you make a lot, like you're good, bravo, but like you're taking time to people most of the time, and like now I just want to show you the content. I don't want to like make typos, and you know, like even the demo that is fully prepared with the YAML file didn't work. Yeah. So like the demo got happened. Anyway, long story, it's Espenso.
Yeah, thank you very much. Another question. Is it possible to, instead of using numbers for SyncWave, is it possible to say, wait for this application or this resource that has this label? Is that something possible?
Waiting about, waiting that application X is finished. No, it's not. As far as I know, it's not a feature. So it's why you really need to think about your SyncWave. So one of the things that I would suggest, what we do here is like, we know, like you've seen my cluster, there's like 15 applications that I installed by default when I use Cube first. And what we do is for each application, we do like we do like 10, 20, 30, 40, which give me a gap between. So if I want to like, oh yeah, there is also that application that I would like to put in, I'm gonna put like in between 15, like in between 10 and 20, I'm gonna put it 15. And the next time I refactor, I'm gonna adjust my number if it's an application that needs to stay in my cluster. Maybe though, there is something you can do like with the pre-sync and post-sync, but I don't think it's made for that, so I would not suggest doing that. So it's why the sync is super interesting, but it can be a little bit of pain with if you want to do those kind of things.
Okay.
It's also why I overwrite the now default way of working with Argo CD because of, where's my manifest? Here, that part, because what I'm saying here, it's even worse for your scenario because now by default Argo CD won't take care about the health of the application. So it's not because Argo CD was like, hey, okay, yeah, I started to deploy MySQL, that MySQL is accessible and I needed to be able to like go to the admin of WordPress, let's say. So those sync wave are really what you want to use to make happen. But at the beginning, it's confusing. At some point, you really get used to it and you kind of like use the sync wave to do mostly whatever you want.
Thank you very much.
My pleasure.
Are there any other questions?
Is there a mechanism to rely on like a webhook from Git instead of having Argo pull every few minutes, or
Yeah.
is it okay?
Yeah. So there is webhooks that you can use within Argo CD. I didn't talk about them because I think they're like a little not that advanced, but like since we only had an hour, so there is webhooks that you can use. One of the things we do also is that they have another project called Argo Workflow that we kind of like integrate within Git. So sometimes we have like GitHub Actions that gonna fire GitHub workflows to do things that we want to do, but like that's a separate project that is not totally made to how we use it, but we use it a little bit like a CI sometime, Argo Workflow, and I would be able to use that not just with the Argo CD webhooks, but like pair it with other stuff like, as I said, my GitHub action. That could be also a thing. Yeah,
Is there any more?
sounds good. Awesome. Thanks for your time, and yeah, hopefully you have a good rest of the not too long conference. I think there was 2-3 talks. Yeah. God, I really want to know my sync wave demo didn't work.
Test, test. Can you hear me over there on the phone in the back row when I speak like this? Okay. Yeah, I
Welcome, everybody. Our next speaker is Guinevere. She has both a background in music as well as software engineering. She works with Pulumi, where she helps users integrate infrastructure, cloud, with running their own applications. I'll let you take it away.
All right, thanks, Steve. All right, hi, everybody. You all read my talk title for the last 5 minutes, so I'm going to skip to the next slide. First of all, yeah, I really love SCaLE. I really love being here. I have the sneaking suspicion that they put me in the last slot on Sunday because they knew I was going to stay for the whole thing anyway. But I'm so excited to see everybody here. Another thing I really love is the ocean. I live in Seattle, and we're not directly on the ocean, but we get so much waterfront with Puget Sound and all that. And so over the last year, I've spent a bunch of time on the beaches learning how to be a beachfront naturalist for Seattle Aquarium, and it's like really cool, all the things you learn about seaweed and, you know, our local whales and shells, seashells, other things. In general, I think computers exist to serve humans, not the other way around, even though in our daily lives it may feel the opposite sometimes. I feel like some days, at least 15% of the reason that I chose to become a software engineer is so that I can show the computers who's boss. I also play piano. The piano is definitely the boss of me. And you already know I write software at Pulumi. We do infrastructure as code, which may or may not be relevant to the story of this talk. Oh yeah, you can find me on GitHub at my name. I'm the only Guinevere Sanger in the whole world. You can find me. So why this talk? Last year, I was tasked to overhaul one of our tools at Pulumi that involved some way of automatically provisioning Docker containers, Docker images, and general Docker functionality automatically using our Pulumi tool. And it turned out we could already do this, but the way that it was done was we wrote code to shell out to the Docker CLI and go docker run dash blah, blah, blah. And sometimes that didn't work so well because sometimes that shell that we were shelling out to didn't have the correct authorization. Or we ran into race conditions. And so when we were deciding to bring forward this tool into the new world of you know, version 4, I proposed that maybe we should use a client library instead of a CLI. And so that's kind of how this talk started, because let's have a show of hands. Who here uses Docker at work? Who here has never heard of Docker? Okay, good to know. Who here has had to write convoluted bash scripts to get Docker to do the thing that they want to do? I'm so glad you're here. Because I was like, what if no one does? And so a couple days ago, I was talking about my talk with a few people, and they said, well, if I just use Docker Compose so that I can just put all my command flags into a file and then have that run in. And I'm like, is that what Docker Compose does? Gosh. Anyway, this person's here in the audience, and they are way better at explaining Docker Compose than the Docker docs, which will be a topic a little bit throughout this talk as well. So what is Docker anyway? You know, it's an open source container platform. It's a very popular container runtime. It runs almost anywhere, and it runs almost anything. One important part of the Docker ecosystem are the container registries, where you can share your wrapped up containerized app with all your friends. And they have a very cute whale logo, which does appeal to me as a beachfront naturalist in training. So, why do we shell out? Ooh, 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 I got some laughters, yes. Go watch Demolition Man, it's a great movie. Well, you know, so this is how most people build Docker images, at least when they get started, right? Somewhere, some process or some person runs Docker build, tag, image name, everything in this particular folder, right? So This looks like a fairly simple command, right? But it's still a command, and you still have to like use a CLI to do it. It's not too bad, right? Like, it's pretty simple, it's straightforward, you know what's going on for the most part. And again, it assumes at least a human operator by proxy. Somebody knows that somewhere this particular command is being run. So we shell out. In Go, which is the language I'm going to use in this talk, that looks like this. And again, that's fine. It's a little bit convoluted, but the Go exec package has actually a few better options to handling. I always find it's a little bit more obvious, but I'm really bad at Bash. And I hear that there are mythical people out there who are, in fact, good at writing Bash scripts. And there might even be a few people out there in the world that are good at debugging Bash scripts. And I'm certainly not one of them. So if my Bash script that runs a Docker command fails, I'm just like, I don't know what to do. I give up. But, you know, as we all know, not all Docker commands are short. I'm not rewriting this in Go for you, because that is also kind of convoluted. So, but again, sometimes shelling out is the right choice if you have a very simple image, if you really just need to like run your development container locally and then get into it or attach something very easily. That's great. Shell out, please continue. But sometimes the shell just doesn't make sense. You know, from the perspective of this whale, he doesn't even know. He can't even see the shells, right? They're too small. Right, so sometimes we want to run Docker processes or build images, right? In a lot of my jobs, when we use Docker, it is to build an image and tag it at deploy time, right? Or at publish time. When we go live with a version, we want to cut a Docker image and push it to a registry. And we also don't want to do this manually, because who here loves release automation? Exactly. We want that stuff to be automated, right? So that's why all these other tools exist. I did put Pulumi on there. Again, I'm not here to sell you on Pulumi. I'm really just here to share some code that can make you bring up Docker images by yourself. So again, why do we use the whale in the first place? It allows us to be flexible. It allows us to have, you know, any environment we want on almost any operating system that we want, and we can control it, and that's actually really great. But, you know, getting into the whys of Docker would be a completely different talk, and as I hinted earlier, I'm not that much of a Docker specialist. I build tools for developers. That's what I love doing. I love making developers happy, and if that means I have to wrestle with Docker on occasion, then I will do that. But I bet there's people in the audience that know more about Docker than I do. And I also bet that, you know, there's areas of Docker that I just haven't even ever touched. So if you want to learn why Docker, their website covers that part. But in short, we should be able to create and use Docker images without the need for an interactive terminal. So I'm going to switch to code. I'm going to switch to my editor here. But if you want to follow along, you can feel free to, I just pushed the code to GitHub this morning, and my apologies, it's incredibly rough. But if you want to follow along, I'll probably push the fixed versions after I go through everything later this week. But yeah, so it's available. Whoops, that's the next slide. So we are going to switch to my Docker Talk repo. All right, so let me make this a little bit bigger, I think. Yes? Does this not, wait, okay. There we go. That'll work for the code. Great, so I have here, in my file structure, I have a very simple sample app. It runs a script that says, hello, SCaLE. I'm going to make this bigger too. There we go. And it has a Docker file that pulls up Go. Wow, this editor's terrible at that. It pulls up Go, and it runs my hello Go file. And when I run this container, it will say hi to everyone in the room, because that's what we do at demos, right? We write hello world, except the world is SCaLE today. Anyway, here is the actual code that I would like to show you. In my main function, the first thing I do is I'm going to go and get myself a Docker client. And so my client library is literally right from here, from the Docker, from GitHub, from Docker itself, and it has a client. And in fact, this is what happens under the hood when you go docker build-t, right? They use this client. They're just like way better than the rest of us at running it, because they can ask the people who wrote all the low-level libraries that nobody else understands. I know you laugh, but this is actually like how it is, and it's been a struggle at times. So again, I needed a way to create a Docker image that didn't shell out to an extra shell, and so this is how we do it. We get a new client, we get some options from our environment. You can actually set a lot of these things. And here's the thing, what you will see here, and then we basically copy a bunch of the things that Docker does. So we create a tar file from our app right here, over here. That's our app. I'm not going to move that, sorry. And then we have some options here. So these are some of the things that we can tweak. These roughly translate to our command line flags. Not quite the same. I'm going to tag my image. gsanker is my Docker Hub name, so I'm just hard coding this for the demo today. My Docker Hub is public. You can look at all of the demo images that I pushed up there throughout my career, and if you have any use for them, good on you. So hello, go. Sunday at SCaLE. Whoops. Don't worry, I'm not going to do a whole lot of typing here. We have a version. This version refers to the Docker builder, and I'm going to use the old builder. This is the original. This is the original builder that you don't even get to use anymore when you use Docker. And I'm going to build for this platform, all right, and then I'm just going to run image build on my client. Everything else in this file is a couple helper functions so that you can all see the output from what happens when I run this program. So let me minimize this guy. Let me make this a little bigger so you can see clear. Whoops. Okay, so I'm here in my demo folder, Docker talk, and Docker v1. Awesome. Wait, hang on, what changed? Oh, that's fine. Right, I changed main.go. And I'm just going to run main.go. And if I did everything right, you should all see some build output now. Now, this is building really, really quickly because I already ran this in my hotel room to make sure that you could all see some output. But this is the output that you see when we're pulling the Golang Docker image, and you see some of this stream output. If we wanted to clean this up, we could parse the output and make it look nicer. I did this, in fact, one of our tools has an interactive print output terminal, and so some of this actually just already looks prettier over there. But this is meant to give you a basic starting point. Cool. So I just built a container image, and I should have shown you this before, but Docker images, here we are, and just 43 seconds ago, I built an image called Hello Go Sunday at SCaLE. Cool. Let's see what happens if I run it. I can run this using the Docker CLI, but because it only prints out, hi everybody, the container exits immediately and you wouldn't see the pretty output. So I will run this one manually for you. Haha, but it won't run. I built it for the wrong platform. I meant to do that. I actually meant to do that. So we can go back here to my program and change the platform. And I'm on ARM64. And notice how this is actually going to be important later because we are only building for this one, actually, yeah, we're only building for this platform. So I'm going to try and run my program again, right? Because I want to build an image that I can then run as a container on my native infrastructure. Sweet. So let's do that. This is going to fail too. Oh, it succeeded. Okay, great. Why did this succeed? Oh yeah, it did succeed because I'm still using the old builder. Right. But now, I'm going to run this. And here we go. Hello, everybody. So that's awesome. Now, a lot of people, when they want to modernize their Docker infrastructure, they ask about build kit a lot. And again, there's a lot of confusion. People sometimes think that Docker build X is the same thing as build kit, but it kind of is and it kind of isn't. What build X is really just a CLI representation of all the features that build kit can offer. And all that build kit really is a builder. So when I ran my Docker images before, you see that there is, you'll see that there's a Moby build kit container repository right here. This basically is a way to allow, it's kind of their way to allow me to run build kit on my machine and build Docker images that have more modern capabilities. Among some of them are the ability to build cross-platform images, to build for multiple platforms at the same time. So I'm going to change my builder type, and I'm going to use build kit here. Because you can still do this with the classic Docker client. And when I say classic Docker client, that is the client that you use to run containers. That is the client that you use to push images. But for a build client, for the client library for Docker build, you actually have two choices. You have a buildx library, and you have what I'm showing you right now, which is the classic Docker library. I'm going to use this. I'm going to try and build for ARM64. This one will fail. Pretty sure. It didn't. Okay, well, this is working great. I meant for this to fail. Okay. So let's see. Where's my images? I just built another one, so that's cool. Things. Great. So, right. No, I know now what's going on. So I have an image. I can build it a number of ways. Awesome, right? So there's a couple other options that you can tweak on these image build options. Some of them work well, and other ones are a little bit in development, or if you ask about it in the Docker community, they will gently tell you, maybe you want to use buildx instead. And I will show you that in a minute. But before I do so, I want to go ahead and actually push this image to my registry, right? So if I have on my auth set up, I'm using super lazy auth. First, I'm going to log into the registry using local auth config. Do not do this in production. Go ahead. There we go. And let me go back here. So right after I built my image and got all that beautiful build output, I'm going to go ahead and I'm going to need to undo some of my imports here. Base 64. Come on. Import package. Thank you. There we go. This should compile. So what I'm doing is, first I need to log into my registry. I use Docker Hub. That's pretty straightforward. Some people use registries that they literally just created as part of their same development stack. One of the awesome things about using a library like this is that it forces you to think about all these things right up front. None of this is going to make you building your Docker containers any easier. It's just moving the complexity in the front rather than at the end of it. So basically, I like this because now I have the ability to basically choose how I authenticate, and I will know because I know what environment I'm trying to run this in, what that environment expects, right? So obviously getting a password like this can totally work. It works for GitHub Actions. You just put it in as an action secret, and there you go. You've got your Docker password. You've got your, you can make the username dynamic. Again, for this demo, I just used mine. And again, you can make the server address dynamic. All this stuff is now obvious to you, and you don't have to like run any kind of like, wait, tell me which registry we're logged into while you're shelling out, because your auth config just knows. So that's one. And then the next thing is we're going to push the image. And I'm just going to go ahead and do very terrible things. Ideally, this would be a variable that I declared on top. But it turns out for me, I always like to be reminded when I'm running through this as part of a demo. So now we have some image push options. Here, we're just passing it the specific authentication. How are we getting into this registry? Great, so hopefully this works, and if it doesn't, now we're going to have to debug. Let's go. Great, so at the bottom here, you see some output from pushing. So, requested access to the resources denied. Let's see here. I wonder if my Docker password is busted. Let me switch real quick, because I did, in fact, grab. Oh, I don't have my Docker password in here. Okay, that's what it is. Let me quickly set this. All right. Export. Docker, what did I call it? I called it Docker. This is great, Docker pass. Pass equals. Here we go. Yes. Clear. Okay. Thank you for your patience. This is what I get for using my direct Docker Hub password in a demo in front of people. Awesome. So this should work now. We're seeing, oh, all right. And now you should see some push logs output. So that's pretty awesome. Neat. So now if I go to Docker Hub, whoops. Where is my Docker Hub? Docker Hub, here we go, and I refresh. We should see a new image called Hello SCaLE. Here we go. All of this without using the CLI. I'm pretty stoked. This is pretty good so far. It's a pretty good start. And I was really pleased when I saw this working on my other tool. Great, so what's next? Sometimes these particular things throw you a curveball. There's a lot of stuff that you can configure. I think I will skip again showing you how to run the container, because again, it's literally just like a client.container run, container start. If you have, it's the documentation on this throughout the Docker repositories is unfortunately sparse. But if you've gotten this far and you have a client, most of the time your IDE will tell you what to do, Cool. So as I mentioned before, this is a client you use to run containers and to push images. But this is not the client you may want to use to build your images, because I will show you in the options right here what happens if I want to build a container image that truly can run anywhere. If I truly want to build a multi-platform container image, you have no idea how many people asked me for a multi-platform container image, and I had to tell them, unfortunately, you're going to have to run a for loop and run this code multiple times and push up multiple individual images, one for each architecture that you want. And they said, what do you mean? I can't just do this? And it turns out you can't. And that's really unfortunate. And I think the Docker people agreed because they came up with a new way of doing this, and that is where the BuildX client library comes in. So let me show you that one. Similar story, we have an app. We have an app folder, it has a Docker file. I'm just running Go because I'm boring. And this one says, hello, BuildX container. Let me show you, it's a little bigger right here. Cool, so in my Go file, my code here, the big difference here is on line 10, we're using BuildX build. And we're using a bunch of other imports. You will see that a lot of these, this whole thing needs a significant amount more setup. So it's a little bit more complicated, but thankfully you all work with Docker, right? You know the pitfalls, you know what things are called and what you want and what you're looking for. So hopefully this isn't going to be too overwhelming. So first we're going to get a new Docker client, then we're setting up a build context. Then we need to get our build options, which this one is, I don't know why this is called PB. It is one of the libraries up here. Where is it? Oh well, let's move on. So we have some build options, and again, this is really just where we're telling our client, hey, please look for my files, please look for my application, my Docker file in the correct folder. And again, this is just where you can keep your Docker context and your Docker file name anywhere, and you can just configure that, which is kind of nice. So then we also have to provision a builder. And this depends on your operating system. And what this does is basically it's using the default builder that Docker uses on my computer. But it turns out you can bring your own builders if you want. I don't know that much about Docker builders, but probably you do. And this is where you would feed those in. And that's pretty cool too. Please apologize. I want to apologize, by the way, for my error handling, because this is literally just a demo script. This is never how I would handle errors, but this way you can all see them when my code falls on its face. So then our builder needs a little bit of setup. We need to load the build nodes. And finally, we're getting to this line, which is our payload, which is our options, which hopefully is where we get to configure some of the stuff. So another thing that BuildX does or doesn't do, it loads our Docker images into its own context, and so a lot of the time when I use this, the image gets built and then it gets put into a secret location on my computer or in some kind of cache, and I don't know where it is because it thinks I'm just building the image and doing something else with it. But maybe I want it in my local image store so that I can run the container and show you all. So that's what this does. So I'm exporting my Docker image to my local image store. Again, it needs a bit more setup. Here we have our payload. I'm not sure that we need these inputs. All right, so then we got a little bit of a helper function for printing. And finally, on line 94, we build. We pass the build context, we pass the builder nodes, and we pass the payload that we defined up here. And the payload really here is, I'm using the default builder as explained here. And this is where we put things like, hey, I want to tag my image. And you already see, I can tag multiple tags, right? So I can tag buildxhello.go. I can tag, I don't know, someone pick a tag name, that's fun. Say what? 3 seashells. Oh yeah, I like that. 3 seashells. Sweet. Awesome. So when I do this, I'll get 2 images. I'll get 1 image, right? But 2 tags. We hope. Let's find out. And then again, I have some support functions that are basically around handling the printing and the authentication. Yep. Oops. I apologize for everything always being on the bottom here. Let's see what happens. It's thinking. All right. Very cool. Docker images. Our moment of truth. Oh, it's not there. Shoot. Oh, no, there it is. Here we are. It's just the same image. It's got a new tag. I was like, no! Anyway, I built this 2 days ago and didn't change it since. That's right. I didn't actually change the print output for you this time. Yeah, so we got this new tag. Y'all can see this just happened, right? Because I definitely didn't have a container here that was tagged with 3 seashells. So that's awesome. And again, now we have a lot more options. What we can do is we can go ahead and Docker inspect this one to see what infrastructure it's built for. Oops, I copied that, right? Inspect. Here we are. So here we get to see a bunch of interesting stuff, and it's built for the local architecture ARM64, which is interesting because I actually didn't tell it which platform to build for. But it picks the one that you're running on by default, which is reasonable, right? So yeah. Let's go ahead and see what happens if we configure this a little bit more. So we can do platforms. Where's my platform here? ARM64. I want to build AMD 64. And this now will be true cross-platform building. Right? Type, what is happening? What am I doing wrong? What? This is very weird. Okay, I think my IDE is just on the fritz. This will be fine. Did I do something weird? Nope. Nope. Oh, wait a minute. Hang on. Can't use string as a type specs.platform. Oh, God. This is fun. Platforms. I swear, this was a string literally yesterday. I should have pinned my version. Sure. Anyway, maybe in the interest of time, I shouldn't debug this in front of everybody, but let it be known that it is absolutely possible to specify multiple platforms. You might have to jump through a few more hoops to do so. I won't show you again this one for pushing this image. You use exactly the same client as before. You use the basic Docker client. It will push your image to any registry that you desire, provided you're authenticated. So that's pretty cool. I'm going to just show you running this container, Docker run, just in the interest of completeness. And here we are, and we have a BuildX container that was made with the BuildX library. So 2 libraries, and let me get back to my slides, because I think I made you a summary. Again, this code lives on this demo repo. I do not intend to maintain it by any means, but I put it up there so you can check it out later. So we have a classic Docker library for building. Classic is a little easier to use. It does support BuildKit, but not with all the options. It does not support all modern Docker capabilities such as multi-platform builds, but you do use it to run containers, to push images. BuildX is way more configurable. It has all of the options that you can do that where people just, yeah, but like if I use the command line, it's like I can do all these things. Yep, you can do all that with the BuildX library. It supports custom builders. Bring your own builder if you need. It also supports BuildKit because it literally is made for it. And as far as I know, it focuses only on build capabilities, and that's what it does. So the Docker ecosystem is huge. And when you look at this, what happened last year was that the Docker community decided to put a lot more effort into like more open source, more public, more usable support for the BuildX capabilities in this way. And I think improvements get shipped every day. And unfortunately, frustratingly, sometimes documentation that was meant for one of these libraries is kind of stuck in the other, and it's very easy to get confused. And so I did not have that great of a time dealing with this last year, hence this talk, because I thought I'd share, so maybe the next person doesn't have to suffer. So there's a little bit more here. So why did I go through all this trouble, right? I think I talked about that a lot, but so yes. I work at a company that does infrastructure as code. One of the tools we do can provide Docker containers. It can build Docker images. And I thought it would be cool to show you yet another way to create a Docker image without using the command line. Well, without using the Docker CLI. Slight asterisk. So let me go back to my code. Here I have a folder called Pulumi. And I did write this in Go. Even though I could have used TypeScript, I could have used Python, I could have used, what are the other ones? .NET. I could not have used .NET to create this demo for you because I have never used .NET in my life. But if you are familiar, you can use this. So Pulumi supports a bunch of languages, but I stuck with Go because here we are, and that's what I've been using the entire demo. So basically, what this is I'm importing two libraries. I'm importing the Pulumi Docker SDK, and I'm importing Pulumi. And what Pulumi does is it creates cloud infrastructure for you using the Pulumi command line. You have to install a bunch of things. I just thought it'd be fun to see. But if you kind of look at this code a little bit, I have my demo image here. It's called demo image. I'm going to call it SCaLE image. I'm going to build it for my own platform, ARM64. Again, same story. I have an app with a Docker file. It does something. I'm going to tag it with my name. And my name is SCaLE image. I'm going to call it Sunday. Great. I'm going to skip push. Great. So this is basically the tool that I built using the Docker client libraries that I just showed you. And this is just a quick little demo here. Pulumi. And I'm going to run Pulumi up. I'm going to create a new Pulumi stack. Actually, let me X out of that and clear so you can all see a little bit better. Pulumi up. Create a new stack. I'm going to call it demo stack. Great. So basically, this should be a little bit familiar if you're at all familiar with Terraform. It's basically going to show you a preview of the resources that I'm creating with the tool. And one of those resources is basically just all the information that Pulumi needs to do this. And then I'm making a Docker image, and it's going to be called SCaLE image. I also get a little bit of a warning here because we want to make sure we're building for the right architecture. That's fine. I think I specified that's the architecture I want. Great. And so now I can hit confirm, and I should see some output if I did this right. So if you were watching really closely, you can see the build output that kind of was displayed in that little message window. I can do that. I can change the thing one more time. But now let's see what happens to my Docker images. So here we are. 18 seconds ago, I created a new image called SCaLE image. And yes, I can also push to the registry doing this. I don't know. So I'm going to skip push, undo skip push. So I think this should just automatically authenticate me because I have my Docker password set, but I don't know. I might need to set up some authentication here as well. Let's find out. So again, I'm just going to like rerun this command. I see, okay, Docker IO repository. Okay, I'm going to do that. You know, I wrote this tool. You'd think I'd know how to use it. It's been months, though, in my defense. Yes, I want to perform this update. I might not be authenticated as part of this program, so that might be an issue. Oh, no, there we go. Awesome. Sweet. So that is kind of just a little sneak preview into what Pulumi does. Let me show you if we can see this on my Docker Hub now. SCaLE image, pushed less than a minute ago. All right, so it works. It's there. Ta-da! I feel like I should do like a little curtsy here. But wait, Guinevere, you say you marketed this whole talk about like no more shelling out. You just used a command line tool to create a Docker image. Yes, but I did not use the Docker CLI. Additionally, it turns out that Pulumi does have ways to automate this kind of thing, and this talk is not about Pulumi, but you do not have to use the Pulumi CLI to use Pulumi. You can run it in a program just as well. We have libraries that help you do that automatically. So you don't have to have a human typing into a terminal, do the thing. You can just kick off the process and have your coffee. All right. Where is my final slide? I think we're at the end of this. Yes, thank you all so much for being here. Last talk on Sunday before the keynote. You can find me at both those things. I don't tweet very much anymore, but I occasionally check my DMs. And I am always on GitHub. Yeah.
We have one question, apparently.
Let's see if I can answer it. Probably not.
First, thank you. It was really cool. Have you looked into alternatives to writing the Docker file itself?
Alternatives to writing the Docker file itself? No, I have not, because that's not what we do. I mean, that was just not part of my job task description, right? You should be able to just feed whatever process creates your Docker file into this as well, right? But yeah, the short answer is I haven't. I just want people to bring their setup and be able to make images. Yeah. But I'm curious about what you were thinking of, perhaps.
Why?
Yeah.
Like why? Just because most Docker files are, it's like the equivalent of a shell script. So just thinking maybe there's a better way than maintaining those by hand.
Sure. Yeah. There's a question in the back.
Do you know if there's any like libraries for alternatives to Docker for building, let's say, like OCI images with this approach?
I don't. I bet there might be. But given that I was pretty convinced most of last year that surely the BuildX library, that the build kit support would be better in the basic Docker library than it is, or more I shouldn't say better, right? Like, I'm sure there were many reasons why it didn't quite make it, but I don't know. I don't necessarily compare container runtimes as like, because again, we don't run this ourselves. We just want to make sure that we have this available for people who do run Docker. That's basically, that's not an excuse, it's just a reason I don't know. Be curious to find out, yeah. Does anyone know of?
Yeah, Red Hat has some tools that are an alternative, like Podman and Builda, and they make OCI images.
Right, I did go to a Podman talk, but that was a very long time ago, 2 days ago at SCaLE. That's a long time. Thank you.
Yeah, I think Red Hat had a speaker here, I believe at SCaLE last year, and that should have gotten recorded, so you can probably find that. Okay. Any other questions? If not, please join me in thanking Gwen for a great presentation.
Thanks for being here.